Hey, Algebra 2 Honor students, this is going to be Unit 5, Day 3 on solving some radical equations. Pretty rad today. If you want to take out some paper, we're going to get started with solving this radical equation right at the top here. And we'll take a look at some quick steps that we can use to solve this radical equation. So if you have to hit pause to kind of copy down the steps first and then go through the process with me, go ahead and do that. But what do we want to do to solve for x? We want to isolate the radical, which is a pretty common theme in solving equations. If we think back to absolute value equations, we wanted to isolate the absolute value expression first. Same idea here, get the radical alone. Then once the radical is alone, how do we undo taking the square root of something? We square it. That's the inverse operation there. So we'll then square both sides, continue solving for x, and then it's very important in these to check your answers. Think back to absolute value equations. Sometimes we get answers that don't quite make sense. And those answers that we get that don't work out are called extraneous roots. So if we get a solution that's actually not a solution, the fancy name for that is it's an extraneous solution or an extraneous root. So if we look at this first example, there's a couple steps that we might take initially to isolate the radical. First one being add 2 to the other side. So we would get 3 times the square root of x plus 2 now is equal to 9. And then really quickly, I would divide both sides by 3 to isolate that radical. So we get the square root of x plus 2 is equal to 3. Now that I've done that, we're at the step where we've isolated the radical, so we can now square both sides. Squaring a radical undoes it, so we get x plus 2 is equal to 9. And finally, subtracting 2 to the other side gives you that x equals 7. So we should really check our answer. Now, it's up to you if you show the check algebraically for now, or maybe just do the check in your head. Some of you do a really nice job with this on tests and quizzes, that you actually show me the check off to the side, which I think is always a good idea. I'm going to just do the check in my head. 7 plus 2 is 9. The square root of 9 is 3. 3 times 3 is 9. Minus 2 is 7. So even if the check is just something quick in your head, I do encourage you to do that, because until you really get used to these, we may not always think about checking for what are called extraneous roots, solutions that don't work. And I promise you, we're going to see it come up in some examples today. So I want you to try these two examples. So try number 1, which is the square root of 2x plus 1 over 4 plus 3 is equal to 8. And then let's try number 2, which is the square root of x minus 4 plus 10 equals 7. All right, go ahead and try those two. Hit pause, see how you do with those two. I'm going to solve them in 1 second here. But I think even just seeing this first example should be enough for you guys to get through these two. One quick note before I solve these is this process might seem somewhat familiar, because we do this when we find x-intercepts of radical functions. We set it equal to 0 on the side. And we've done a little bit of that work where we had to isolate the radical and then square both sides. So if this looks familiar, it could be because we did that earlier on when graphing radical functions. So the first thing I'm going to do in number 1 is subtract 3 to the other side. So we get the square root of 2x plus 1 over 4 is equal to 5. Go ahead from there and then multiply both sides by 4, right, to get rid of dividing by the 4. So we get the square root of 2x plus 1 is now equal to 20. All right, now that I'm on to this stage right here where I've isolated the radical, now we're at the step where we square both sides. So 2x plus 1 is now equal to 20 squared, which is 400. Subtract 1 to the other side. We get 399. And no need for a decimal here. You can leave your final answer as 399 halves. Okay, 399 over 2 is the final answer to this first one. And I promise if you double check it, you should get back to the same answer, right? 2 times this would just be 399 plus 1 is 400. Square root of 400 is 20. Divided by 4 is 5. Plus 3 is 8. Quick check there. All right, number 2. It's a pretty quick step to isolate the radical. Square root of x minus 4 equals 7 minus 10, which is negative 3. So I've isolated the radical. Go ahead and square both sides. Negative 3 squared is 9. And if I add 4 over, we get that x is equal to 13. And we're going to say, okay, let's move on to the next one. But if you were in class, I bet you'd be shouting at me right now. You'd be like, no, Mr. All, don't go on to the next one because, of course, we have to check. Because what happens is that 13 minus 4 is 9. The square root of 9 is 3 plus 10. 3 plus 10 is 7? I don't think so. Oh, boy. X equals 13 is not a solution. In fact, this equation altogether has no solution. So we saw that happen back in the day for absolute value equations, like I mentioned earlier. Sometimes you isolate the absolute value, and we know at a certain stage in the game that it's just not going to work. How did I know this one wouldn't have worked? When you got to this stage, before you squared both sides, I'm just going to write it one more time. Do we ever take the square root of a number and get a negative output? The answer to that is no. I know sometimes we write plus or minus, guys, but it's not in this instance. It's when you take the square root of both sides that we write plus or minus. If the square root's already there for us, when you plug in a number for x, the only outputs you can get from that are positive numbers. You'll never get -3, hence why this value doesn't check out. So you can stop at this point in the game, just like we did for absolute value back in the day, and say, you know what, this has no solution. So consider that for future examples. Make sure you check in on that before moving on and continuing to solve. Let's go ahead and try another one. So if I gave you, we're going to step up our game a little bit in this one. So I'm going to give you 3 times the square root of 2x plus 2. When does that equal 2x minus 2? Okay. So for something of this form, the reason why this one's a little bit different is that you have variables on the other side as well, whereas all the others just had a constant on the other side. When we put variables on both sides of the equations, you know, it does make things, I think, a little bit more complex algebraically, but nothing that we can't handle. And you'll see what this is going to turn into in a minute. Now, I'm actually going to break my own rules already. What are the rules? The rules are isolate the radical in the first step. So technically, I guess we should divide both sides by 3. But since 3 doesn't go in evenly to either of these terms, right? I mean, if this was like a 6 and a 6, yeah, I probably would start by dividing the 3 over. Since 3 doesn't go in evenly, though, I actually am going to leave it on the side with the radical. Now, we have to be careful when we do that, because in the next step, we know that we square both sides. So we'll just have to be cautious about what happens when I leave that 3 out front over here. All right, so go ahead and square this side, square this entire side. We know that squaring this gets rid of the radical, so that's just left with 2x plus 2, but I also have to square that 3. So this is not just 3 times this, it's actually 9 times the quantity 2x plus 2. So just square each of those individually. And could I have done that for something like, I don't know, maybe this stage up here? Could I have squared both sides and left the 3 on that side? Yeah, I guess so. I mean, I prefer that you didn't. If it's easy enough to divide the 3 over, then go ahead and do that. Because that was going to make this one more messy, I kind of like leaving it on this side and starting by squaring here. When you square a binomial, do not distribute the square. Drives me nuts. It's like one of my biggest pet peeves as a math teacher. It's not a thing. You can't distribute that square in. You have to multiply this out. So you're either going to FOIL this times itself, or you're going to do box method for me, whatever works best for you to figure out what the product 2x minus 2 times 2x minus 2 is. I'm going to just write out what that product is. This would be 4x squared. And you're going to get 2 negative 4x terms, so that's going to be a total of negative 8x, and then plus 4. Notice how distributing the square in really only gives you these 2 terms. It doesn't give you the middle inside term, which is critical here. All right, well, now that we have something that's quadratic, it's getting a little bit more complicated looking. We're going to go ahead and clean this up. So distribute the 9. 18x plus 18 is equal to 4x squared minus 8x plus 4. And now we can go ahead and continue the factoring here by setting this equal to 0. So I'm going to subtract 18x to the side, subtract the 18 over, and in standard form, you're going to get the quadratic 4x squared. Subtracting 18 gives you minus 26x. Subtract this 18 from 4, you get minus 14 is equal to 0. So in terms of solving this, at this point in the game, even though you have other methods for solving quadratics, I'm going to say that these are going to be factorable. It's maybe not the easiest thing to factor, but one thing that you might notice is that it does at least have a GCF of 2. And rather than just factor the 2 out on the outside, since we're solving, you can divide both sides by 2 and reduce those coefficients to 2x squared minus 13x, and then minus 7 equals 0. And I hope that you have a decent level of comfort factoring things that look like this. You need some sort of strategy as far as how do we break this down into a factoring sense. But if you want off to the side, could you do another box where you say, all right, the things that multiply to 2x squared are 2x and x. I know that the things that I put in these spots have to multiply to negative 7, which is some combination of plus or positive 1 or negative 1 and 7. Okay. But I know that these have to give me a total of negative 13x. So I have to figure out where do I put the 1 and the 7 and which one's positive and which one's negative such that I get a total of negative 13x here. Well, it appears to me that if I put minus 7 up here, that's negative 14x. And I put positive 1 down here, 1 times x is 1x, that these combine for negative 13x. So even though we sometimes have to stop a little bit when we get to something like this and think carefully about the factoring, I couldn't have put the 7 with the 2x. That wouldn't have worked out. But there's not that many possible combinations to try to get that we get 2x plus 1. And then over here, we're going to get x minus 7. So if you set each of those equal to 0, 2x plus 1 equals 0. Really quickly, you would subtract 1 and then divide by 2 to get x equals negative 1/2. And then we get x equals 7 on the other side. So when we think about the algebra associated with the initial questions we started with today compared to this one, yeah, I mean, we've definitely upped our level of difficulty when I look at these two compared to this number 3 right here. We get a quadratic. When you get a quadratic, you got to set it to 0 and then use a factoring technique to get these two solutions. But oh, wait, I'm not even done, because what have I not done? I haven't checked the answers. Do they both work? What you're really concerned with, by the way, is this right side here. If I plug in one of those answers and this side is a negative in the original equation, I can take the square root of something and get a negative answer. So if you test negative 1/2, that's going to be a problem. 2 times negative 1/2 is negative 1, minus 2 is a negative 3. So I already know that negative 1/2 doesn't work. And I'll tell you, x equals 7 does work. If you check it real quick, 2 times 7, that's going to be 14 plus 2 is 16. 3 times the square root of 16, that's 12 altogether. Okay. Over here, you would get 2 times 7, which is 14, minus 2, which is also 12. So 7 is the only solution. X equals negative 1/2 is what we would call an extraneous root. It looks like a solution, but in the end, it doesn't wind up checking. So you have to be cautious as far as that goes. But hopefully the process here algebraically makes sense to you about how, in this case, I broke my rules a little bit. I didn't isolate the radical, but that's actually okay. All right. Let's move on to something like this example here. The square root of x plus 6 minus the square root of x plus 3 is equal to 1. Okay. So for something like this, my first step that I've listed in our steps is isolate the radical. And oops, we actually can't do that. Because I can try and isolate the radical by, let's say, adding this radical x plus 3 to the other side. So I would get radical x plus 6 is equal to 1 plus the square root of x plus 3. But notice how, again, there's radicals now on both sides. It's not really that we've isolated this radical, because there's a radical on this side too. So at this stage in the game, this is the best that we can do to kind of get one of the radicals alone. And I am going to stop at this point and say, let's square both sides. Okay. So if you have a double radical in your equation, I would say get them on opposite sides and then go ahead and at this stage, square both sides. What you're going to find is when you square both sides for examples like this, is that this right side will still have radicals in it. This side is fine because what does the left side become? Just x plus 6. But on the right side, again, what you have to think about is we're doing 1 plus radical x plus 3 times itself. So if I think about what that becomes, 1 times 1 is 1. 1 times radical x plus 3 is radical x plus 3, and that same thing will happen down here. What happens when I do radical x plus 3 times radical x plus 3? Isn't that just x plus 3? Okay, right? Because it's like saying x radical x plus 3 squared, which is just x plus 3. So altogether, what does this become? I'm going to actually carry my work down here. The left side is x plus 6 still. The right side is 1 plus, hey, these radical x plus 3s, we have 2 of them. So the middle term is 2 radical x plus 3. And then at the end, plus the quantity x plus 3. So that's kind of a tougher step, but make sure you're okay squaring that binomial and maybe doing the box method off to the side, or if you can do that in your head, of course, that's fine as well. But you have to be able to get to this in the next step. So now what's the goal? The goal would be, well, we only have 1 radical left now. Now isolate this. So we're going to work on combining some like terms and kind of moving things to the other side to isolate the radical x plus 3 there. So if I combine some like terms, we get x plus 6 equals 2 radical x plus 3. The only like terms are actually this 1 and this 3 right here. So it's going to be a plus x and a plus 4. And what we notice happen that's actually kind of nice here is the x's drop out. If you subtract x from both sides, those go away, which I think makes our job a little bit easier, at least in the end. If I subtract 4 to this side, because remember, we're still trying to isolate this, subtract the 4 to the other side. Now this is a 2 over here. 2 equals 2 times square root x plus 3. And before, remember, I left the 2 on the side when I squared both sides in number 3. Because 2 divides into this 2 over here evenly, I think we can take that step to isolate the radical one step further to get 1 equals the square root of x plus 3. And finally, now we can square both sides. So for something that looked pretty complicated to start, once I do that step of this box method multiplication over here, then I just got to do a little bit more algebra to isolate radical x plus 3. So we get 1 equals x plus 3. Finally, subtract the 3 over to get a final answer of x equals -2. Oh, wait, we can't get negative answers, can we? We sure can, okay? I know we rejected -1/2 as a solution in the last one, but -2 is going to work. If you go back to the original and check it, plug it in for x here and here, it will turn out that it checks out. Okay, so it's not that negative solutions are bad. We got to check them in the end and make sure that they're not extraneous roots. Okay, we're going to do 2 last ones real quick here, and these are very quick. Oops, this is actually number 5. Counting's hard. All right, number 5, we got the cube root of 2x plus 5 equals 3. All right, so you've already noticed, I think, what's probably different about this one. Now we're solving a radical equation where it's not the square root anymore, it's a cube root equation. So you're still going to subtract 5 to get started. Isolate that cube root term. Cube root of 2x equals -2. And then from there, at this stage in the game, if this was a square root example, I would stop and say there's no solution. Can't take the square root and get a negative. But guess what? You can take the cube root of a number and get a negative solution. So cube roots of negative numbers work. Is okay. Because a negative times itself 3 times is a negative. So you're allowed to proceed with this equation by the way, don't square both sides. How would I get rid of the cube root of both sides? We've got to cube it. Okay, so just pay attention to what that root sign is. All right, so then from there, we're going to get that 2x is equal to -2 cubed, which is -8. -2 times -2 times -2. Divide the 2 over to get x equals -4. So it's not that this is a challenging one to solve, but I think we can get hung up in not if we don't remember that the cube root of a negative is okay. And if you plug it back in, 2 times -4 is -8. The cube root of -8 is -2. And then plus 5 is 3. Okay. So the last one that we'll do is the 4th root of x plus 18 minus 1 equals 3. So just to show you that, again, we don't necessarily have to deal with solving radical equations in terms of the square root always. Here's a cube root example. Here's one with a fourth root. And although they may look scarier at first, I promise this one's not so bad, guys. Add the 1 over to make this a 4. So then from there, to continue solving, we have to think about, how do I get rid of the fourth root in this case? You're going to raise both sides to the 4th power. And by the way, you have to be careful with fourth roots, because if it's an even root, this number on the side can't be negative, can't. Since it's a positive 4, I know that we can continue and find a solution here. And if you don't remember what 4 to the 4th is, well, I guess you can grab a calculator quick. It should be 256. Okay, so this is now x plus 18 equals 256. And then 256 minus the 18 gives you a final answer of 238. I don't know if I've showed you yet how to type this into the calculator, so that's the last thing I'll show you really quick. If I were to plug in 238 for x again, how do I do the fourth root of that number? So if you come over to the calculator, if you hit the math button, it's option number 5, which says x root. So we can do cube root pretty quickly by doing choice 4. But if you choose option 5, you can now type in whatever root you want to that little box there. So we're taking the fourth root of, what was it, 238 plus 18. I don't even have to do that math in my head, even though it's 256. And then from that, we subtracted 1. And is the answer truly 3? And of course it is. So you can do fourth roots, fifth roots, whatever you need here. But I think that this should be sufficient enough that you guys now have a pretty solid understanding of solving equations with radicals. Remember, radical doesn't always imply square root. Cube root and fourth root, still in play. All right, let me know if you have any questions. Have a great rest of your day.